Have you ever looked up at the night sky and wondered, why aren't all the stars crashing into each other? It turns out this simple question led to one of the most perplexing paradoxes in cosmology. Welcome to Bentley's paradox. Back in 1687, Isaac Newton published his groundbreaking work, The Principia. In it, he described the law of universal gravitation. You know, the apple falling on the head thing? Well, it's a bit more complicated than that. Newton's law states that every particle in the universe attracts every other particle. The force depends on their masses and the distance between them. Sounds simple enough, right? But then in 1692, a young scholar named Richard Bentley had a thought. If everything's attracting everything else, why isn't the universe just one big clump? He wrote to Newton asking two mind-bending questions. First, in a finite universe, wouldn't all the stars collapse into a single point? And second, in an infinite universe with infinite stars, wouldn't each star be torn apart by infinite forces pulling in all directions? Newton's response? Well, it was complicated. He agreed with Bentley about the finite universe scenario. Yes, everything should collapse into a point. But for the infinite universe? Newton had a different take. Imagine you're a star in an infinite universe. You've got stars pulling you in every direction. Left, right, up, down, and all the directions we can't even visualize. Newton argued that in this case, all these forces would cancel out. The star wouldn't move at all. Problem solved, right? Not quite. Newton realized that there was a catch. This perfect balance would be incredibly unstable. One tiny nudge, and the whole system would fall apart. So how did Newton explain the universe's apparent stability? He suggested that God was constantly making minute corrections to keep everything in place. A continual miracle, he called it. Now, before you roll your eyes, remember, this was the 17th century. Science and religion were often intertwined. Plus, Newton didn't have the tools we have today to tackle this problem. But let's fast forward to modern times. What do we know now about Bentley's paradox? Well, it turns out that both Newton and Bentley missed something crucial. They assumed the stars were static, not moving. But we now know that stars are in constant motion. In fact, a finite number of stars moving around can avoid collapse. They can orbit each other, just like planets orbit the sun. This motion creates a kind of balance, preventing everything from crashing together. But what about an infinite universe? Here's where things get really interesting. Modern cosmology, based on Einstein's theory of general relativity, tells us that an infinite static universe filled with matter would indeed collapse. It's unstable, just like Newton thought. But here's the twist. Newtonian physics actually predicts the same thing. We just needed more advanced math to figure it out. Math that wasn't available in Newton's time. So was Bentley onto something big? Absolutely. His paradox touches on a fundamental question in cosmology. How can a universe full of attracting objects be stable? This question led to some groundbreaking discoveries. For one, we now know the universe isn't static. It's expanding. Edwin Hubble observed in the 1920s that distant galaxies are moving away from us. And not just from us, but from each other too. The whole universe is stretching out like a balloon being inflated. This expansion counteracts gravity's pull. It's why we don't see everything collapsing into a single point. But wait, there's more. Remember how Newton needed God to keep tweaking things? Well, modern cosmology has its own mysteries. We've discovered dark energy, a mysterious force that's causing the universe's expansion to accelerate. We don't know what dark energy is, but it's acting against gravity, pushing everything apart faster and faster. And here's where Bentley's paradox makes a comeback. Some scientists think the universe might eventually stop expanding and start contracting. This could lead to what we call the Big Crunch. Imagine all the matter in the universe coming back together, crashing into a single point, just like Bentley wondered about over 300 years ago. But don't panic yet. The Big Crunch is just one possible fate for our universe. Current observations suggest it's more likely the universe will keep expanding forever. So what can we learn from Bentley's paradox? First, asking simple questions can lead to profound insights. Bentley wasn't a famous scientist. He was just a curious mind pondering the nature of the universe. Second, even the greatest minds can miss things. Newton's continual miracle seems naive to us now, but it was the best explanation he had with the knowledge available at the time. Finally, science is a journey, not a destination. We're still grappling with questions Bentley and Newton pondered centuries ago. Our answers are better, but they're far from complete. The next time you look up at the night sky, remember Bentley's paradox. Think about the delicate balance that keeps our universe from collapsing. And wonder, as Bentley did, about the mysteries still waiting to be unraveled. Who knows, maybe you'll be the one to solve the next great cosmic puzzle. After all, it all starts with a simple question. Why isn't the universe just one big clump?